have this down, we'll go ahead and I'll start talking about it. Remember yesterday we had that big long equation. We talked about if this term and this term, if A and C were the same, were equal and positive. Okay, I think I forgot to add that part to it. They must be equal and they must be positive to be circles. In order for in order to be an ellipse, A and C must both be positive. Okay, so for circles, they must be positive and equal. For ellipses, they must just both be positive. If A and C are both positive, then that's how we know that we have an ellipse. All right, so notice we have two different equations, and this is what I consider standard form of an equation. Okay, so when I ask you for standard form or general form or write an equation of an ellipse, these are the forms that I expect it to be in. Notice the x value is going to be first, and the y value is second, and it equals 1. Okay, that's going to be standard or general form of an ellipse. What's different about horizontal versus vertical is the a squared and the b squared. The a squared is under the x, which is the first term. Then it's going to be a horizontal. Okay, because think about it. X moves left and right. X equals 1 is to the right, to the 2, another to the right, 4, 5, 6, and so forth. If the b squared is under the x, then that means the shorter leg is under the x, and the longer one is under the y, because a and a squared is always the bigger number. Okay? In ellipses, a squared is always the bigger number. Now, this is for ellipses only. When we do hyperbolas, there's going to be a different set of characteristics. Okay? So for ellipses, the a squared is always the bigger number. So if the bigger number is first, it's going to be a horizontal ellipse. If the bigger number is second, it's going to be a vertical ellipse. And that's how you can determine what a and b are and then square them to find different parts of the ellipse. Then there's the equation to find the foci. C squared equals a squared minus b squared. You will have to know that. None of this stuff you will be given. You must know everything. And the more you work these, the easier it becomes. Okay? It's going to become very logical as you actually do these on your own. A, B, and C. When we ask you for A, B, and C is not a point. Okay? A is considered the distance from the center to the vertex. The vertex is an actual point. So you can figure out the vertex by knowing what A is and what the center is. Okay? B is a distance. So A, B, and C cannot be negative. A coordinate point can be positive or negative, but the actual value A, B, and C cannot be negative. So B is the distance to the center to the covertices, which are the shorter distance from the center to the vertex, center to the vertex, center to the covertex, center to the covertex. And then if you start at the center and go to the vertex one way, and the vertex the other, that means it's two of them, which is 2A. Same thing for the minor axis is 2B. Major axis is going to be the bigger. Minor axis is going to be the smaller. And only ellipses have a major and minor axis. So in a minute when we're doing the problems and it just gives you a center and it tells you the major axis, that right there tells you that it's an ellipse. Obviously today we're doing ellipses, so everything's going to be an ellipse. But tomorrow when we do circles and ellipses together, you won't know if it's a circle or an ellipse unless you look at the A and the B, A and the C value, or it tells you it has a major axis, you know it's an ellipse. It tells you it has a radius, you know it's a circle. So there are different things that each of them have that you can tell. And then this is probably not something you did in Algebra 2, the eccentricity. You just have to know that the eccentricity of an ellipse is C over A. So sometimes you're given the eccentricity or you have to find it. It just helps you figure out what those letters are when you are writing an equation of an ellipse. This next one just labels everything. Notice the major axis is the longer one. Horizontal. The horizontal is the longer. For vertical, going up and down is the longer. The green is the minor axis. It's the shorter one. Then notice you have your covertices are the endpoints of the minor axis. Your vertices are the endpoints of the major axis. And then you have the foci. Be sure when you're graphing it, the hardest thing to remember is when you're graphing an ellipse is to remember to plot those foci. And then the center isn't labeled right there, but you have the center in there too. And you don't draw the major and minor axis. Okay, that's not part of your graph. It's just there so that you can see how you get it. All right, so this first example gives you an equation and then asks you to find all the stuff and then graph it. The order that you do that in is up to you. I kind of do it in a certain order. You have to find standard form first, okay? And then I list the major axis, A, B, C, the center, the eccentricity, and then I graph it, and I pull the vertices off the graph. If you want to get the vertices and then graph the vertices, you can do that. It's up to you the order you want to do it in, okay? So first, we have to look at that. So we know this is ellipses, so we know it should equal 1. But if we didn't know this was an ellipse, we'd have to figure it out. We look at the A value and the C value. We have 1 and 16. They're both positive, so that means it's an ellipse. Ellipses must equal 1. So we have to divide everything by 64 in order to get it into standard form. So our standard form is x plus 1 squared over 64 plus y squared over 4 equals 1. So now that you have it in standard form, now you can find some things. I usually start with A, B, and C. A is always the bigger number. So if A squared is 64, A is 8. A is a distance, the distance from the center to the vertice. Therefore, it is not plus or minus. It is only the positive. A is a distance. B is a distance. B squared is 4, so B is 2. C, we use our formula. C squared equals A squared minus B squared. So C squared equals 64 minus 4. C squared equals 60. So C equals the square root of 60. 60 is 4 times 15, so 2 root 15. We always simplify. So C is equal to 2 root 15. Because we're going to use that to find, we're going to use A to find our vertices, B to find our covertices, and C to find our foci in a minute. And we can go ahead and write the major axis. The major axis is 2A, so we can say that's 16. It doesn't ask for minor axis, but if it asks for the minor axis, that would be 4, 2B. The center, I'm going to go ahead and write that because we can do that right now. The center is negative 1, 0. And we can actually find the eccentricity also at C over A. So 2 root 15 over 8 can be simplified to root 15 over 4. Always simplify completely. 2 root 15 over 8 isn't wrong, but it's not simplified. So you're going to get points taken off if it's not completely simplified. So at this point what I do is I like getting the vertices from the graph. So I'm going to go to the graph and plot the center. So we have negative 1, 0. And then I'm going to plot my vertices and covertices and then write them down. So since A is my distance from the center to the vertex and it is under the x in my standard form, that means I'm going to move left and right. So I'm going to move to the left and the right 8 units. So here it's just 1 off the graph. So there are my vertices. I'm going to go ahead and write those down. So 2, 4, 6, 8. So that's going to be negative 9, 0. And 7, 0. Again, you can write them down first and plot them. You can plot them and then write them down. The order that you write this stuff down in doesn't matter. Then the covertices is going to be how far I move up and down. So I'm going to go up 2 and down 2. So I can list those covertices as negative 1, 2 and negative 1, negative 2. Or if you learn to write those together, you could write it as negative 1 plus or minus 2. If you want to write those together. I do not care. What I do care about is this. You can't write the vertices as negative 1 plus or minus 8 because you know what negative 1 plus 8 is and you know what negative 1 minus 8 is. You must actually find them. Okay? You can't have two integers with a plus or minus sign in between. You have to actually find those numbers. If it's not an integer, then you can leave it plus or minus. Be sure that you don't just connect the dots and make it look like a diamond. It is not a diamond, it's an ellipse, so it's like a smush circle. And then the foci, we have to plot those also, and they are a distance of 2 root 15 from the center. We don't have a calculator, so we have to think about this root 60. So we don't know what the square root of 60 is right off the top of our head, but we do know the square root of 49, we know the square root of 64. 60 is in between those two perfect squares, so it's going to be in between 7 and 8. So 1, 2, 3, 4, 5, 6, 7, between 7 and 8. 1, 2, 3, 4, 5, 6, 7, between 7 and 8. So there are your foci. Be sure and plot them. Your foci for an ellipse will always be inside the ellipse. If your foci are outside of the ellipse, you've done something wrong. Okay, they're on the same axis. They're on the major axis always. And they're inside the ellipse. So now, the way we write those foci, this we can do all together if we want, and we don't know exactly what that point is. So we can't write exact numbers. We don't have a calculator. So we started at -1, and we went to the left, so we subtracted 2 root 15. We started at -1, and we added 2 root 15. So you can say -1 plus or minus 2 root 15, and then the y value stayed at 0. Or you can write those as two separate. You can say -1 plus 2 root 15, comma 0, and -1 minus 2 root 15, comma 0. Does not matter to me which way you write it, but you do have to recognize both ways. All right, then we have the domain and the range. Domain and range. Domain are the x values. So the lowest x value up there on the graph is -9. The highest x value is 7. Range are the y values. The lowest y value is -2. The highest y value is +2. And those points are included in the domain and the range. Questions? All right, this next one requires you to do some completing the square. So again, if you are not very good at completing the square, you're going to have to do it for every single conic that we have, sometimes multiple times in the same problem. So first we need to line up the x's and the y's. So 9x squared, 54x, y squared minus 2y. Bring the constant to the other side. Then you want to complete the square, but you can only complete the square if the leading coefficient is 1. So if the leading coefficient isn't 1, we have to factor out that 9. And remember, we do the x and the y's in the same problem, but separately. So this 9 doesn't come out of everything. We're only dealing with the x's, and then we're only dealing with the y's. But don't turn it into a multiplication problem. It's still a bunch of terms being added and subtracted. So x squared minus 6x. Half of -6, 3 squared is 9, so add 9. Since we factored out a 9, we have to multiply 9 times 9 before we add it to the other side. Then what's nice about this, we don't have to factor anything out for the y's, so that makes it a little bit easier. Half of 2 is 1, 1 squared is 1. If we add 1 to the left, we have to add 1 to the right. So we end up with 82 minus 73, which is 9. So again, the 81 and the 1 came from putting 81 on the left, we have to put it on the right. We put a 1 on the left, we have to put a 1 on the right. So it stays equal. And now the whole point of completing the square is so that you can rewrite it as a binomial squared. And then again, it's an ellipse. If it wasn't on the ellipse notes, how do we determine what that is? We look at the numbers in front of the x squared and the y squared. They're both positive, but they're different, so that makes this ellipse, so it means it needs to equal 1. So we divide everything by 9. And remember, we don't want a 1 in the denominator. 9 divided by 9 is 1. So this just ends up being x minus 3 squared plus y minus 1 squared over 9 equals 1. All right, so A, B, and C. A is always the bigger number, so A squared is 9. That means A is 3. b squared is 1, that means b is 1. So then our c, so c squared equals a squared minus b squared. C squared equals 8, so c equals 2 root 2. C squared equals a squared minus b squared. A squared and b squared are in the standard equation. If you get a negative number right there, that means you flip-flop the order. You've done the wrong thing. Okay, you will not get a negative value for c squared equals. Okay, you will not get an imaginary number for c, a, b, or c. You will never get an imaginary number. If you get an imaginary number for a, b, and c, you've done something wrong with your equation. The major axis is 2a. And then we can also kind of determine, is the major axis vertical or horizontal? Because the bigger numbers under the y, the major axis is going to be vertical. Might be nice. You can leave yourself a little note right there so that you know what it should look like when we graph it. The center, HK, so 3, 1. The eccentricity, C over A. And then I'm going to go to graphing it. So the center is 3, 1. And then we know it's vertical, okay? Or we know there's a 1 right here, so that's how we're going to move on the x-axis side to side, and there's a 9 under the y, so that's how we're going to move on the y-axis, okay? Y goes up and down, x moves side to side. So the major axis is vertical, so that means we're going to go up 3 and down 3. For the co-vertices, over 1, over 1. So there's your ellipse. We can list those vertices now. So the vertices are going to be 3, 4, and 3, negative 2. It doesn't matter what order you list those in. The co-vertices are going to be 2, 1, and 4, 1. And then the foci, 2 root 2. Remember, that's the same as the square root of 8, so it's going to be a little less than 3. So there's the foci, there's the foci. And the way we write that, so the focus started at the center and went up and down, so that means the y value changed. So from the center, 3 stayed the same, and from 1, we went up and down to root 2. The foci are always on the major axis. So if the ellipse is up and down, the y value is going to change for the foci. If the ellipse is horizontal, side to side, then the x value is what's going to change of the center. And then the domain and range is just the x and the y values. So the lowest x value is 2. The highest is 4. For the range, the lowest is negative 2. And the highest is 4. And notice the vertices and the co-vertices versus the domain and range. You can figure out like the co-vertices and the vertices. Now, the vertices doesn't always match up to the domain or the range. It depends whether it's vertical or horizontal. Okay? But in this case, the vertices are going to help you with the range. The co-vertices are going to help you with the domain. Those should always match up. If they don't, you've done something wrong when you wrote it down. Now, will we always ask you to do all of those things? No, okay? But we might just say graph it. You have to be able to graph it. Or we might just give you an equation and say write in standard form. Or give you an equation and say what are the vertices? Or what is the eccentricity? Or like these next ones, it's going to give you some parts of the problem and you have to write the equation. Drawing a picture is always helpful, especially because it'll help you with the vertical or horizontal, because that's going to be the biggest part of this, is being able to know where to put the a squared and the b squared. So it gives you a center of 0, 0. So right away we know x squared over, we know y squared over equals 1. Okay, that's a given. We know that much already. Now we just got to figure out where to put the a squared and the b squared. And if you can do that without drawing a picture, that is fine. I'm going to draw a little picture. So we know the center is 0, 0. We have a vertex over here at 7, 0. So the distance from the center to the vertex is A, and it tells us, or it doesn't tell us, but we know from 0 to 7 is a distance of 7. Because that's the vertex, we know it's going to be horizontal, so that number is going to be under the x. So 7 squared, 49, is going to be under the x. Then it tells us the minor axis is 2 units long. So the minor axis is 2b. It is 2 units long. Therefore, b is 1. B squared is also 1. When we write that, our final answer should not have a 1 in the denominator, so we should just write it just like this. Okay? No 1s in the denominator. If you need to write it and then rewrite it, or leave it off to begin with, hey, writing it is fine, just in your final answer, don't have it, because anything over 1 is just not completely simplified. And if we give you a problem, like if I gave you this and expected you to graph it, the 1's not going to be there. So I want you to recognize that so that you know it doesn't mean it's not an ellipse or it's 0 or it doesn't exist. I want you to know how to get that value. All right, this one gives us the covertices and the eccentricity. So remember, eccentricity is C over A, which equals 4 over 5. Now, before we just say that A is 5, we have to make sure, because sometimes that's a simplified version. It has to match up with the other information it gives us. So depending on how much information it gives us, we don't want to start with the eccentricity. Okay? So we want to start with the covertices. It tells us we have covertices at 0, 1. So there's a covertice. And at 6, 1. So if those are covertices, that means right in the middle is the center. And this distance right here is B. So if we have a covertice at 0, 1 and 6, 1, that means our center is going to be 3, 1. So we know x minus 3 squared over something, y minus 1 squared over something equals 1. And we can figure out what b is, since we know the center is 3, 1 now. So from 3, 1 to 6, 1, that gives us information that b is equal to 3. And that moves left and right, so 9 is going to go under the x. Because the covertices are horizontal, that means this one's going to be vertical. So now we do use that information with the eccentricity. Since the eccentricity is 4 over 5, c equals 4 and a equals 5, so a squared is 25. Questions? All right. Also on this problem, like on the quiz next week, it's just going to say, write an equation. It's not going to say of the ellipse. It's going to say of the conic. And so you have to know what that is. If we gave you this problem tomorrow, hey, then the difference between circles and ellipses, you would know. Circles don't have eccentricity. We only deal with eccentricity with ellipses and hyperbolas. So if this was on the ellipse and hyperbola quiz, we'd have to give you a little bit more information. Okay, there's not quite enough information to figure out if it's an ellipse or a hyperbola, but it is enough information to know the difference between a circle and an ellipse. Okay, so just be aware, on the quiz next week, when it's everything, it's going to say, name the conic, and you're going to have to figure out what it is. It's not going to tell you this is an ellipse, write an equation of an ellipse, write an equation of the conic. Same thing here. If this was given to you tomorrow, and you're given a center, a focus, and a vertex, you know right away that that's an ellipse. It's not a circle. Circles have a radius and a center. Ellipses have a lot more stuff. So we know the center is 2, 5. We know the focus is 5, 5. And the vertex is 7, 5. So here we have 2, 5, 3, 5, and 7, 5. Now, however much you want to draw, if you don't need to draw a picture, it is fine. I am not going to look at the picture. It's just there to help. So the center's given. So x minus 2 squared over something, y minus 5 squared over something equals 1. We know that c is the distance from the center to the focus. So 5, 5. From 2, 5 to 5, 5, that's c, which is 3. That doesn't help us with the equation. It's going to help us in a second, though. And then the distance from the center to the vertex is a. 2 to 7 is a distance of 5, so a is equal to 5. Because a moved left and right, that means our 25 is going to go under the x. And now we just have to use our equation. C squared equals a squared minus b squared to find b squared. So 9 equals 25 minus b squared. Bring the b over. B squared equals 25 minus 9. So we get 16. No need to take the square root of that. We don't care what b is. We only care what b squared is when we're writing the equation. Now, if you wanted to subtract 25 and get negative 16 equals negative b squared and then divide by negative 1, it's the same thing. Okay? You get the exact same answer. All right, so that is